my dear student, I'm Saktwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of fluid dynamics for our subtopic of viscosity and turbulent flow. This will be the last session for our topic of fluid dynamics. So welcome to proceed with our discussion here. But before we continue, we are supposed to remember where we ended on the last session. On the last session, we tried to see the relationship between the velocity and also the time. This we looked about the graph that shows the relationship between the velocity and also the time. And that graph give us the meaning of the terminal velocity. How can we get the terminal velocity? That is what we tried to see. That we say that the terminal velocity, this is the maximum velocity whereby an object reach at the maximum point or attain. Hapo ndo tunasema ni maximum velocity, kwamba inapotokea object ina move inafika kwenye maximum level, hiyo ndo inatupatia terminal velocity. And we say that the terminal velocity by formula is obtained by taking the 2r square, then bracket the density of the object minus the density of the liquid. Then we divide by the 80 times the coefficient of viscosity. That is what we tried to demonstrate on the last session. For our today discussion here, we are going to see examples related with that we learned on the last session. We have our example number 5.6, and our example said that a small oil drop of radius r for with the terminal velocity of 2.0 exponent -1 meter per second in air. Find the new terminal velocity of the oil drops of half of this radius. Now imagine we have the fluid, or we have the liquid, and that liquid, my dear student, is placed or is located either inside the glass and so on. And we take the small drops, we take the drops and put it inside the dose of the liquid. Now we have been told that that oil drops fall with radius, contain the radius of r, and then fall with the terminal velocity. It fall toward it fall downward, my dear student, toward with the terminal velocity, as we see here. We have been given in air, in air. Therefore, find the new terminal velocity of the oil drops of half of this radius. Sasa tumeambiwa kama tulikuwa na oil drops, na ile oil drops iliweza kufall inside the liquid or inside the oil with the terminal velocity of 2.0 exponent -1. Now, what is the new terminal velocity if the rain drops? If the oil drops is half of that of the origin. That is what we have been given, we have been asked on our question here. Now, if we observe here on our question, we are supposed to consider only two drops. We first of all, let us look for the first drops, and also we'll jump and see for the second drops. But for the first drops, we could take the terminal velocity. It means V1 must be equals to 2 bracket this density of the drops. Then we minus by the density of the oil. We times by the acceleration due to gravity. Then times the radius square, or the distance of that rain drops. Wanasema ni nusu kipenyo. So then we divide it by 9 times the coefficient of the viscosity. This will be our equation number 1. And also for our second dropsy, second oil dropsy, we should say that we get the terminal velocity, my dear student, by taking the same formula, but the radius here will be a differ. The radius will change because we have been told that the radius is a half. It means the oil dropsy is a half with that of the first drop that we have been given. So here will be the same formula, but the radius will be changed. This will be the radius 2, and that will be the radius 1. But after this one, we have been prepared only 2 equations. The equation for the first oil dropsy and also the equation for the second dropsy. Now, we are supposed to take these 2 equations and divide it. Let us take equation 1 and divide it by equation 2. If we redo that, my dear student, we should obtain that before we divide here. We are supposed to substitute the radius 2, which is a half of the second radius. Now, if we divide, we should obtain that the first terminal velocity divided by the second terminal velocity must be equals to 4. Must be equals to 4. The ratio of that terminal velocity must be equals to 4. Now, how can we get this one? How can we get the new terminal velocity or the velocity of the half of the oil drops? How can we get it? Now, we get this one by applying the concept of the exponent and radical that we learned on Form 2. We tried to say that on that topic we have one of the subtopic which is called the transposition. Thinking it is transposition. That subtopic concerning on how you can make it the formula. You can make it the value at the subject. Now we are supposed to use that concept so that we can make it a V2 at the subject. How can we make it a V2 at the subject? We are supposed to, my dear student, to reciprocate that. Let us reciprocate these ratios at the left side and also at the right side. If we reciprocate, we should obtain a V2 divided by V1 is equal to a half of that is equal to 1/4. It means it's equal to 1/4. Now let us make a V2 at the subject by multiplying it by V1 at both sides. If we multiply by V1 at both sides, we should obtain that the new terminal velocity must be equals to V1, then divided by 4, as we see here. Now, after this one, my lovely student here, we are supposed to take the value that we have been given, the first terminal velocity of the rain drops. Let us take it and substitute into our formula here. If we substitute here, it means that instead of writing V1, the terminal velocity of the first rain drops, we are supposed to substitute that first drops which we have been given into our equation, which is equal to 2.0 exponent -1. Now we should substitute here. If we substitute and simplify, we will obtain that V1 must be equals V2 must be equals to 0.2 meter per second. Then we divide it by 4. If we divide this one, my dear student, we should obtain that the new terminal velocity must be equal to 0.05 meter per second. This is the velocity that we have been asked on our equation here. Now, let us conclude by saying that therefore, the terminal velocity of the second drop, because we have been given 2 drops. The first drops which contain the terminal velocity of 0.2 or 2.0 exponent -1, And also this second drops must contain the terminal velocity that should cause it to fall down, which is equal to 0.05 meter per second. Or if you want to express in terms of in centimeter, you could convert this one, and it will be equals to 5.0 exponent negative 2 meter per centimeter per second. So this is the terminal velocity that we have been asked on our question to find it. So now let us proceed with another example, because we have two examples on this session. The first example we tried to see. Now let us see the second example, which regard us to explain, to provide the reason about this statement.